what we are coming to look at is the intersection. Okay, so here the set of objects which belongs to A, and so we can see it over here, a type of set which belongs to A and at the same time belongs to B is called the intersection. So when they are belonging to the both of the sets, so it means it's an intersection. Okay, now let's look at it. This is how it is being written. When you see something like this, this is the members of the set. We can see set A is equal to 2, 4, 6, 8, and set B is 1, 4, 8. And let's move on. We have A intersection B, which is what? 4, 8. So now how do we find our intersection? Somebody will ask, how do we find our intersection? If you see this symbol, we did everything in our first video, so we won't stress on it that much. So how do I find my intersection? Any member found in the both of the members or the sets. So if I find a number in A and I find the same thing in B, it means they are intersecting. So those members should be brought out as their what? Intersection. Now let's look at an example. This is a diagram illustration showing, so you can see that the shaded part is denoting the intersection. So this A, so if I'm taking A only, should be from here up to here. So only here should be my A only. My B only is here to here. But if I want the set of B, I will take it from here up to here, the whole circle there. And if I want the members of A, I will take it from here to here. Why? Because even the intersection members are part of A and B. Are we good? Yes, so that is intersection. So let's move on to, we are continuing other types. So we have disjoint sets. Disjoint set. Let's look at disjoint set. So disjoint set, if no member of a set belongs to set B, and then the set A and B are disjoint what sets. So there's no member in A which is also found in B, so we call the disjoint set. Let's look at an example. This is an example of a disjoint set. The disjoint set can be found if there is no intersection. That means if this member A, this set A, and this set B, when I find their intersection and we can't find any. So if I take set A, I have 2, 4, 6, 8. Set B, I have 1, 3, 5, 7. You can see that they are not common, so there's no intersection. So this is how it is being drawn on the Venn diagram. A is separate and B is separate. And this is our universal set. We all know it. Okay, I told you it's the set of what we are, or what we'll be talking about. So if I take A and B together, it gives me our universal sets. Can be we can get other sets from the universal sets. Okay, so this is our disjoint set. Let's move on. Okay, so this denotes our union sets. So this is our union set. When we take the union set is formed by putting two sets together in particular. Okay, putting two sets together in particular. So the union of set A and B is the set of the members that belongs to either A or B or both. So that's the union set. So if you take the union set, we are combining what? A and B together to get union set. And if you are doing for union set, if you see a member in A and then it is also in B, we write it as one figure in the union set. We don't write the two numbers. Okay, so you can see that set A is having 1, 3, 4, 5, 7, and set B is having 3, 4, 8, 9. And I started by what? The list, that is the 1 from set A. So 1, 3 is found in A and B. I cannot write the 2, so I write one of them. And 4 also is found in both, but I'll write 1. And I'll write the 5, 7. I'll continue with my 8 and what? And 9. And let's look at some diagram. You can see that in our first diagram we said that only this part, this region, was the intersection, but in this point we are finding for union sets. So it's all the sets found in A and then found in B all together. So the shaded part shows the union set. The shaded parts shows the union sets. Okay, so let's move on. Let's take an example. This example 2.20. We are given that if P is equal to S, which is said that X is a factor of 16, and Q is equal to S is said that S is a multiple of 4 less than or equal to 16, and R is equal to 11 less than X, which is less than 16, and we are to list the elements of P intersection Q, P intersection Q intersection R, P union Q, P intersection Q intersection R, and P intersection R. So how do we do this? We know the table I brought earlier. I listed most of this. Okay, so we'll be looking at them. So let's look at how to solve this. Let's look at how to solve this question.
Okay guys, this example 2.20, from our question we were asked if P is equal to X, is said that X is a factor of 16. Okay, so we are to list the factors of 16 and listing factors of a number. I did it in my previous video, so you can go back to my channel and watch it. So I listed the factors of 16 starting from 1 and ending on 16. So every factor has itself and 1 included. Okay, and Q is equal to X is said that X is a multiple of 4 less than or equal to 16. So multiple of 4 less than or equal to 16. So I just list the multiples of 4. That is you can find it on the multiplication table we have. Okay, and R is equal to 11 less than X, which is less than 16. So if we are having that, we are not supposed to start from 11 because it states that we are not it's not 11 less than or equal to, but it's 11 less than X, which is less than 16. So we have to start from 12 and end on 15. Okay, so that is it over here. So the first question was we should list the elements of P intersection Q, and this P intersection Q. So any element found in P and Q, we list them down as intersections. So we can find 4, 4, 8, 8, and 16, 16 here. Okay, so this is it over here. And P union Q. P union Q is all the members or the elements in P and then Q. So we list all of them over here. So we have 1, 2, 3, 4. So if there's 4, 4 here, we list only one of them. Okay. And then the 8, we are having 2 here, but we list one of them. Okay. The third question was we should list Q intersection R. And this Q and R. So anything in Q and R, we are listing them. So when we look through, I think we are having 12. Okay, so 12, 12 here, 12 here. So that means we list 12 as the answer. And Ivy said we should find P intersection into brackets Q intersection R. Okay, so to find this, we need to find the one in the bracket first. So how do we find Q intersection R? We just come here, Q and R. What is here and here? So we just found it here. That is 12. So we bring the 12 there. So P intersection 12. What we should it should give us something. So P intersection 12. When we come to P, we don't have 12 here. So that means it should give us a null set or an empty set. Okay. And then the last one is we should find P intersection Q intersection R. So we first look the one in the bracket, and the one in the bracket is P intersection Q, okay? And P intersection Q
Okay guys, so we just looked at example 2.0. We'll continue um, with complements of a set. This is another set we are coming to look at, complement of a set. A complement of a set is a subset of universal sets U, and then the complement of A is the set of the members which belongs to the universal set but does not belong to set A. So if we have a particular set which has a member, okay, and these members can be found in the universal set, but the universal set has some specific members which cannot be found in the they belongs to set A, okay, and then they cannot be found in set U, or let's say universal set that gives us the complement of set A. So the complement of set A is when the set or the members of set A belongs to set U, but the members of set U does not what belongs to set A. That is the universal set. So let's look at an example. We have a universal set of 1, 2, 3, 4, 5, 6, and then set A is 3, 4, 5. We can see that set A is in U, but there are some members in the universal set that is not found in U. So those members are called the complements of the set. Let's look at a diagram here. There's a diagram here. So this is what I was talking about. Let's look at the diagram here. This is how to list or draw the diagram for complements. Okay, this is how to draw the complement, the diagram for complement. The complements are listed outside the circle. They are listed outside the circle, so mostly they are found here. Okay, so all members, when you see a Venn diagram listed here, shows the complements. Okay, now let's move on. Let's check an example on what we just talked about. Let's check an example. So this is an example. A and B are subsets of a universal set U, and this is the universal set U listed over there. Okay, this is it, the universal set U, and the set A is what? Even numbers. I did type of numbers, so you can check my channel and watch it, how to figure out even numbers, multiples of 3, how to do multiples. I've done the video, and list the elements of the set A, B, A complement, B complement. So we will know how to do that. A intersection B, A union B, A union B complement, A intersection B complement, and A complement intersection B. And we have to illustrate it on a Venn diagram. So let's quickly look at how to do that. So this is how we are going to solve our question. Let's look at it.
Okay, guys, this example 2.28. Okay, so we're given a union or universal set in a question, and we're giving set A to be even numbers. Okay, so this is a set of even numbers. Because the universal set is ending on 18, so I ended on 18. So 2, 4, 6 to 18. And B says we should list the multiples of 3. So the multiples of 3 are ended on 18. Why? Because the universal set is ending on 18. And A complement. Okay. So the questions we are given is we should list the elements of the sets A, B, A complement, and B complement. So if you see something like this, it is called a complement. Okay, because of this here, it's called a complement. So how do we set out the complement? Is we've already talked about it. Okay, so this is the complement. We list out our complements of A and B, and then the first question was we should find A intersection B. So this A intersection B. So anything found in A and B that are common, then we list them out. So you can find 6 and 6 here. So the out 2 is out, 8 is out. A union B is we are combining all A and B and we write them down. Okay, that is basically the universal set. Okay, and we are asked to give A union B complement. A union B complement this here. So A union B complement, we first found we've looked for our A union B. Okay, these are A union B. Then we come to the universal set. What is in here that what is in the universal set that cannot be found here? Okay, then we list them out, which becomes our complement. And A intersection B complement, we know our A elements already, and we know our A complement elements already, so we just look at their intersections. And we have A complement intersection B. So we have our B element, we have our A complement element. We just list out their intersection. Okay, and this is what we had. And the last question is, I should illustrate it in a better way. So this is the better way. And this circle is for A, this circle is for the elements you are seeing in the center here is the intersection. Okay, and then this is the elements for A, this is the elements for B. And those you are seeing outside here are called the complement. Okay, they are called the complement. The ones outside there, this is the universal set.
Okay, so this is the solution for example 2.28. Okay, so let's quickly go for a short break, and we'll continue on our next video.